So in this video, we're going to start arithmetic sequences. An arithmetic sequence is something in which we add the same number to get each consecutive term. For example, we could have 2, 5, 8, 11, 14, 17, and so forth. If you notice, what's happening here is to get from 2 to 5, we're adding 3. We're always adding 3 to get each term. So to make sure a sequence is arithmetic, we need to make sure we're adding the same number to each term. An example of a sequence that isn't arithmetic would be something like this: 2, 4, 7, 11, 16. Now, the way we know this is not arithmetic is because to get from 2 to 4, we're adding 2. To get from 4 to 7, we're adding 3. If you notice, the difference between each term is changing, so there is no common difference, which leads us to this term right here. In the first sequence we talked about, the common difference is going to be plus 3 because it's a change between each term. And D is going to stand for the common difference. Now, let's move forward. We're going to write the rule of an arithmetic sequence. So the first thing we're going to do, and there's several ways to do this. So for example, let's say we have 12, 7, 2, -3, -8, and so forth. So the way your textbook does it, and it depends on your choice, but this is method 1. And this is from the textbook, so keep that in mind. Remember, a sub n was the general rule for a sequence. We're going to say a sub 1 plus n minus 1 times d. Now, let's just label each term. A sub n is our general rule. N is going to be the term that we're dealing with, so whatever term of the sequence we have, so the nth term. D is going to be the common difference. And a sub 1 is the first term of the sequence. So if we look at the sequence we have up there, we can say a sub 1 is 12 because this is the first term of the sequence. Also, we can determine the D because to get from 12 to 7, we subtract 5. So our D value is going to be -5. All we have to do to write the general rule is we put in our a sub 1, and the n is going to leave unknown because we don't know the n is when we have the general rule. So I put in my n and my d. Let's flip this around just to make it a little bit easier. So we get 12 plus -5n plus 5, which leaves us with a sub n equaling 17n minus, a sub n equals 17 minus 5n. Now, my method I like to use is a little bit easier, but it just depends. Again, our sequence was 12, 7, 2, -3, -8. In my method, I don't really show much work, but this is what we need to know. Our common difference, again, we can determine because we're subtracting 5 to get to each consecutive term. Now, I don't really worry about a sub 1, but what I do know is my common difference is I always go with this formula. A sub n equals d sub n plus a sub 0. So Since my d is negative 5, this is going to be negative 5n. Now, a sub 0, we haven't really labeled, but the way I get this is if I'm subtracting 5, I'm going to go back one term. Meaning, what can I subtract from 5 to get to 12? And that is 17. So I know this has to be negative 5n plus 17. Let's try one more. Example 2. Let's say we have 19, 23, 27, 31, 35. Okay, we're going to get the common difference like we did before. So our common difference, in this case, we're adding 4 each and every single time. So our d equals plus 4, and watch out for the sign because that has to be there. Next, a sub 1 equals 19. It's the first term of the sequence. And this is if you're following the textbook. And if you need to, write out the formula. 19 plus n minus 1 times 4. At this point, we should be able to distribute the 4, and we get our rule being 15 plus 4n. If you want to write 4n plus 15, it really doesn't matter. Now, my method, again, same thing. I know my common difference, except I use this formula. I know my d is going to be plus 4, so I know it's plus 4n. If I'm adding 4 to get the next term, I'm going to subtract 4 to get the term before it. And this is my a sub 0. And this is going to be 15. So we get 15 plus 4n.